So you're not done hearing about Zephyr, I guess. I think you're stuck with us for at least another 30 minutes. Next session is Zephyr as well. Zephyr is everywhere. Like it's deployed in millions, probably tens of millions of devices out there, all the way from, you can hardly see, but behind there is a wind turbine, so running in really big machines, really small medical devices, hearing aids, laptops. I don't know how many of you have Chromebooks or Framework laptops, but that runs Zephyr as well. Embedded microcontrollers, embedded controllers there run Zephyr, home automation, you name it. And I'm sure you guys know here in the room, building a product, it takes quite a few skills. It takes a village, right? And it's not even mentioning the hardware design, but software-wise, embedded is only a small aspect, right? Like you need to build backends and front ends, and you need to sprinkle some DevOps in the mix and data pipelines and whatnot. But luckily, there's lots of innovation happening, and we don't have to reinvent the wheel. When it comes at least to things like the backend, the front ends, etc., we've been like over the last few decades, containerization, microservices, new programming languages, probably way too many front-end and JavaScript frameworks, new programming languages, things like GitHub that help with all things DevOps and help people collaborate, etc. So lots of innovation keeps people's technology stack relevant, basically keeps people excited about technology, and the same is happening in embedded as well, right? We have that's a different pace, right? Like the embedded space, embedded technology. Rest says hi, but essentially we work with different constraints, right? And we probably don't always embrace all those modern software engineering techniques that we saw in the previous slide. And this is kind of where something like Zephyr comes into the mix. You may hear about Zephyr referred to as Zephyr, the Zephyr Project, Zephyr RTOS. It's a bit of everything. It's effectively what helps people be productive, efficient when it comes to building embedded solutions. And at the heart of Zephyr it's an RTOS. Like it's a real-time operating system, a kernel, if you will, something that helps you make sure that whatever your embedded product has to do you will fit everything that you need to in this small microcontroller. Processing data, processing events, make sure that sensor monitoring works alongside your battery management, alongside your LoRaWAN connectivity backend thingy. And that's one of the things that Zephyr does. So it's certainly that, but it's a few other things. It's effectively all you need, all the bunch of features you need to build a full-blown solution. So on top of the low-level kernel, you will have lots of abstractions for helping you manipulate your file system and interacting with the storage on your flash storage, cryptography, sensor interaction. All that basically sits, and that's something that's been in Zephyr pretty much since day one, sits on top of a really strong hardware abstraction layer and an abstraction of all the device capabilities, so that effectively when you write a Zephyr application, you're not tying yourself to a particular silicon vendor. You're writing code that's effectively independent from the underlying hardware. So more on that in a few minutes. And then we keep stacking things up, which again we will also talk about in a few more details in the next few minutes. But there's even a higher level of abstractions. Like you have maybe over here you have some kind of abstraction of what a display controller is. But then what you want is actually build high-level graphical user interfaces. So we have those kind of application-level services in Zephyr as well. And beyond, it can also be in the third-party ecosystem. If that graphical user interface you want to build, you want to use Qt, well, that's also available. That's not part of Zephyr proper, but it's available for you to consume as a Zephyr-ready sort of embedded library, which you can source from third-party vendors and so on. So Zephyr has been around, it's actually turning 10 years old in just a few months. We will probably celebrate this at Embedded World, so in just a few, next spring, I guess. It's turning 10 years old, and it's a really, really active community. Thousands of, if you do the math, it's really a lot. Thousands of contributors. I sent the slides really late to the organizers. Sorry about that, but they're already still. Although I put that together a couple days ago, by now it's probably you can add to that a couple hundred additional commits, and we have hundreds of maintainers looking after Zephyr. And like I said, and Zephyr, to put it on the map, in terms of open source projects out there, like the top 30 open source projects over the last year or so, in terms of velocity, activity, number of contributors, number of issues being tackled and problems being solved, it's up there. It's actually not even in the top 30. It's number 19, I think, in that leaderboard alongside PyTorch, VS Code, Home Assistant, and Homebrew, a bunch of others, ARM toolchain, Linux kernel, not so. Linux is number one, but it's right there on that leaderboard. So a lot is happening, and there's a lot of things that one expects from an embedded SDK, an embedded framework. Like when you build an embedded product, one way or the other, all those things in this on this chart, you will need. You might not need everything at the same time. You might not need the best power efficiency at the same time as you will want the best performance, as well as like super strong security, or maybe you will. But the thing with Zephyr is that it provides a bit of everything, and you can really tweak it to whatever it is you need. So there's a baseline of features that are available, and then you can enable what you need when you need it. One thing that I want to get out of the way, starting with those two sort of axes on the map, taking a step back, Zephyr is like 10 years old. And 10 years ago, that chart I was showing earlier with like all the stacks, it was essentially the same. Like we've been using this this sort of approach where we abstract we have a device, hardware device abstraction, and we have all those services that stack on top of one another. 10 years ago, and even to this day, some people tend to push back on the fact that, hey, you know what, this is embedded. Don't bring us abstraction layers. This is going to bring us bloat and overhead, and this won't fit on our small constrained microcontroller. Except that when you look at it, like Zephyr is actually, you don't have overhead. Like if you compare it to other RTOSes out there that have way less flexibility, way less abstraction layers, effectively we're as fast as it gets, right? But yet we provide way more flexibility. So those don't bother. Take pictures if you want, but don't bother necessarily trying to make sense of all those numbers. They are available online, all those benchmarks, and you can run them on your hardware of choice and see for yourself. But yeah, performance, when you need performance, you can get performance out of Zephyr. No problem about that. But what's more, like I said, you also get the flexibility, the configurability. There's a few things. Sometimes people compare Zephyr to Linux. Definitely some similarities, although different targets. Like we are after the microcontrollers and the really small constrained devices. But things like kconfig come from the Linux world. So in a nutshell, it's effectively you only enable what you need in Zephyr, and you can really finely tweak like all those features, all those drivers that you pull into your system. You can really finely tune what it is you enable. Your sensor might have some advanced features that you don't require. You just don't enable them. You know that they will have an impact on the power consumption and so on. It's just like literally one flag away to enable or disable them. And kind of related to this, and also inspired by the Linux ecosystem, is something called device tree, which is, again, in a nutshell, something that helps abstract the underlying hardware. And you think basically of the different hardware peripherals that you need to bring into your product. You basically pull in drivers, just like you would in Linux, right? And Zephyr already has hundreds and hundreds of drivers for sensors and all the sorts of peripherals that you would need. And so you describe what is the hardware that you have on your PCB, on your device, and then Zephyr and the Zephyr build system does all the rest, does all the magic for you. Something that's really important, and I think some of you in the room, like when you start a new project, you go with like silicon vendor X, and they have you install whatever SDK, IDE. If you're lucky, it's going to work on Windows, Linux, and Mac. Most likely, it will work only on Windows. This will make some of your developers unhappy, and you start a new project, and you have to start all over again. It's really hard to get a stable developer environment. So that's one thing that pretty much also since day one, Zephyr has been looking at, and that's one of the things that's made Zephyr successful. In terms of developer experience and onboarding, you can get from zero to a working developer environment in literally minutes, and that working environment will provide you with the same commands to build code, debug code, flash code on whichever supported target in Zephyr is always going to be the same. Like, you don't require extra tools, and no matter whether you're on Windows, Linux, and the Mac, you will mostly have the same experience. Also, something that's kind of like a modern-ish approach to software engineering, which unfortunately is not something you necessarily see all that much in embedded development, is testing, continuous integration. In Zephyr, we have something called Twister, which is effectively a testing framework, which we use a lot, of course, internally to validate that the Zephyr kernel, all the Zephyr subsystems, services, all work as they should. So we do a lot of that internally, but that's also something that we very much encourage people to use in their own developments. So the things that Twister do is effectively run unit tests, integration tests, but also things more advanced, like every night in my lab, I want to make sure that I don't have any regression in terms of power consumption. Write basically tests and test cases for checking that the power consumption of your device is what it should be. Testing a GUI, like pointing a high-resolution camera at a display, at the LCD display of your product, and effectively have tests that pass or that fail based on whether your GUI is what it's supposed how it's supposed to look like. So that's quite nice. We use it again quite a lot internally for dog fooding, I guess I could say. So those are the numbers from last weekend's run. We ran literally 500,000 tests every weekend, and even more so whenever there's like a new pull request and commits and whatnot to spot regressions, etc. So that's also, I think, quite unique in the sort of in the industry, and even like for embedded, having all this open source automation available is quite something. Works on emulators as well. For testing or even like for development purposes, you don't necessarily have to have a like real full-blown hardware and sensors and so on to test a tiny ML algorithm for your vibration detection thingy. Maybe you can simulate part of the system, right? And you can run some of it on your local machine by just simulating sensor data. It's still going to feel and look like a full-blown application, except that some bits will be emulated or simulated. And so we support quite a lot of emulation technologies and techniques. And yeah, so there's that. There's a few other accesses I guess I could dive into. Security is another one. So this time it's not Rust who says hi. I guess it's CRA. As you can see here, we're already pretty well sort of prepared for all things CRA pretty much since day one. We've had, like I said, things like continuous integration, but even beyond, static code analysis, coding guidelines to enforce like MISRA compliance and things like that. Really well-defined processes so that we, whenever a vulnerability is being reported, we disclose it to our users and adopters responsibly. All things SBOM, software bill of materials. You are literally, and I'm not kidding, one click away from getting a full-blown software bill of material for your Zephyr-based firmware. So knowing what are all the like source files, etc., that you're pulling into your binary is something that Zephyr supports out of the box. And many other things that you would expect, which Zephyr has. Connectivity. Name a connectivity protocol. It's likely supported in Zephyr already. LoRaWAN, sure, here at the Things conference, but industrial protocols, all things internet, and TCP/IP protocols, USB, BLE, you name it. And safety should be probably here on the map. Power management, I could do an entire presentation of how Zephyr addresses power management like throughout the entire stack, so that you have the best power consumption as possible, and you can use Zephyr for really, really low power solutions. But at the end of the day, it's all about the open source community, right? And so my call to action is one, like check out look at this for yourself, go on GitHub and Discord, etc. But you will see that Zephyr is an incredibly active community. Every week, it's like 6 new contributors. Last month alone, it's like 350 plus unique contributors that made one way or the other a contribution to Zephyr. It is huge. Like that's a fact, I guess. And so my call to action is go home. I mean, not now, in a few hours, and take Zephyr for a try. Take one of your existing product designs, start migrating to Zephyr and see how that looks like. Like how would that feel like to start using device tree to describe all your hardware, get inspiration from all the 100 plus, 500 plus code samples that we have, existing boards that are supported. Give it a try. Find us online. The community is here to help. Here also talking about thousands of individuals that will happily take and answer your questions. And yeah, that's what I had. Thank you.
Not to be okay. It's okay not to.
Maybe for beginners, Dev Academy I would like to recommend.
Sure.
It's best for everyone who's starting up in Zephyr. Go through it.
Right.